In this video, I'm going to show you how to obtain the geometric series formula and then how to use it. So we remember that a series is a sum of terms. So a geometric series is a sum of terms of a geometric sequence. And we denote it with a capital S with a little n. So I'm going to show you how to get the formula. So let's say that the sum is equal to T1. And then the next term, let's say, is T1R, where the ratio is R. And the next term after that would be T1R squared, and then plus T1R cubed, and so on. So the very last term we know is going to be T1R to the n minus 1, because that's the term of the last term or the general term. So the term before that will be T1 times R to the n minus 2. All right, now when we did the arithmetic series formula, we had it written backwards. So what I'm going to do this time is something a little bit different. I'm going to take my first sequence and I'm going to times it by R. Both sides. So I now have SNR equals T1R plus T1R squared plus T1R cubed plus T1R to the 4, and so on. So the second to last one will be T1 and then R to the n minus 1. And then we multiply the last term by R, we get T1R to the n. Now I'm going to draw a big long line and I'm going to subtract. Now, to make this so that I don't have any negatives, what I'm going to do is I'm going to take the second sequence, or the second series, I should say, and I'm going to subtract it from the first sequence, or series, I should say. So what I have is NR minus SN. And then you'll notice that if I subtract the second series with the first series, all of these are actually going to cancel off because they're identical. So this happens all the way down to here. So all the terms in between, from here to here, including this part here, will all be canceled off. So what I'm going to have left is T1R to the n, because remember I'm taking the second series and I'm subtracting the first one, minus T1. All right, so now what I'm going to do is on the left side, I'm going to factor out S sub n. So I have R minus 1. And then on the right side, I'm just going to leave it. Okay, and then I'm going to divide both sides by R minus 1. And then I'll have my formula. Now, sometimes you'll see the formula with the T1 here also factored out. So I'm going to write this as Sn equals T1, and then in brackets, R to the n minus T1, minus 1. And then all divided by R minus 1. Okay, so the same thing as before. We know that T1 is our first term. R is the common ratio. N is the number of terms. And S sub n is the sum of the first n terms. And then Tn is our nth term. Now, the reason I'm going to show you that we need that is I'm going to show you another formula. So what we can do, I have an OR here. We know that Tn for geometric sequence is T1 R to the n minus 1. So if I actually multiply both sides by Tn, multiply both sides by R, I'm going to have TNR And then on the right, I will have T1 r to the n. So remember back here, we actually have T1 r to the n. Okay, so I'm going to substitute T1 r to the n into the formula. So let me write that down. So substitute TNR into the above equation. Okay, so we have T1R to the n, and I'm going to substitute now TNR. So to get Sn equals TNR minus T1 all divided by r minus 1. So if we have the first term, we can use this first formula, but if we have the last term or the nth term, we can also use the second formula. All right, so let's take a look at a question using this formula. So find the sum of the first 8 terms of the following series. So we'll do this first one here where it's 4 plus 8 plus 16. So listing what we know, we can see that T1 is 4. R, the ratio is 8 divided by 4, or 16 divided by 8, which gives us 2 in both cases. N is 8 because we want to find the sum of the first 8 terms. And then S8 is what we're looking for, so we don't know that. So we're going to substitute into the first formula because we don't actually know Tn here. So we have 4, and then in brackets, 2 to the power of 8 minus 1. And then we have in the bottom 2 minus 1. So plugging all of this into your calculator, you should get 10, 20. All right, let's take a look at another formula, another question where we use the second formula. So what does that look like? So in this case, this is find the sum of the geometric series. We have -1 plus 5 minus 25 plus, and then dot, dot, dot to this big number, negative 390, 625. So T1 is -1, R is -5, we don't know N, but we know Tn is -390,625. So we want to find the sum of the series, and according to this formula here, we don't need to know what n is, whereas in the first formula, we do need to know n. So since we don't know n, but we don't need it for the second formula, we can plug those numbers in. So we have -390,625 times the ratio of -5, and then plus 1, because T1 is negative, all divided by -5 minus 1. And then just plugging all of these numbers into your calculator, you get -325 and 521. All right, I'm going to show you one more question, kind of like an application of geometric sequences. So it says find T1 and T3 if the second term is 24 and the sum of these 3 terms is 126 for a geometric sequence where it's T1, T2, and T3. So we don't know T1, we don't know R, we know there are 3 terms, and we know the sum of these 3 terms is 126. We also know that the second term is 24. Now, using the fact that the ratio is R, the previous term would be 24 divided by R. And we could say the third term is 24R. So if I add up these 3 terms, I will get 126 because it says the sum of the 3 terms is 126. All right, so let's see if we can solve this. We're going to multiply everything by R so that we can get rid of the fraction. So we get 24 plus 24R plus 24R squared equals 126R. Let's move everything to one side, and we'll write it in descending degree order. So we have 24R squared plus 24r. Oh, sorry, not 24r, because we're going to subtract the 126. So now we'll get negative 102r plus 24 equals 0. And this actually is going to reduce. I'm going to divide everything by 6. So 4r squared minus 17r plus 4 equals 0. And then I can see this is factorable. So I get 4r minus 1 and r minus 4. That equals 0. So r equals 1/4 and 4. So plugging in, if r equals 1/4, I can see that my first term would be 24 divided by 1/4, which equals 96. And then the third term would be 24 times 1/4, which equals 6. Now, if r equals 4, however, T1 would be 24 divided by 4 equals 6. And then T3 would be 24 times 4, which equals 96. So we have two sequences, even though the numbers are the same, but we don't know if the sequence is increasing or decreasing. So we can have 6, 24, 96, or we can have 96, 24, and 6.